It's a graph that is broken into pieces. So the formal definition is a graph that is represented by two or more equations. So each equation is a piece of the graph. So if you take a look at the screen, you will see an example of a piecewise function. And you can see that on the graph, we have two different graphs. We have graph 1 here that is decreasing, and then we have graph 2 here that is increasing. You can also see below the graph that we have two functions written, and this first function represents the first function here on the graph. I'm going to number them for you so you can see. And then the second function is the equation for the second function on the graph. So you can see here how this definition of piecewise function is actually derived. It's derived from two different equations graphed on the same graph. And sometimes those two equations, when graphed, don't form a continuous graph like we're used to seeing. This is called a discontinuous graph because this graph breaks right here at x equals -5. And so we'll talk about that in a second. So the first thing we're going to do is go through some of the elements that we've already talked about with functions and apply it to piecewise functions. So the first thing we want to know is, what is the domain of this function? So remember, your domain is related to your x coordinates, or the inputs. And as I look across this x-axis, I can see that this function goes on forever here in the negative direction, so towards negative infinity. And then this graph goes on forever towards positive infinity. So that indicates that this is most likely going to be a domain of all real numbers. However, what I need to check out is this break where it's discontinuous. And here where it's discontinuous, notice that this is an open circle, which means that x equals -5 is not included on this graph. Okay, so it's everything less than x equals -5, but x equals -5 is not included because that's an open circle. But on x equals -5, there is a closed circle for this graph. So that means that x equals -5 is included on this graph. So x equals -5 is included on this graph as a whole because it's included with the second equation here. So we can say for sure that our domain is going to be all real numbers. The range is also going to be all real numbers because, again, it's continuing down towards negative infinity and up towards negative infinity. So our range is also going to be all real numbers. Since this graph is discontinuous, we can identify where the graph is discontinuous. And we always want to identify that with the x coordinate. So this graph is discontinuous at x equals -5 because here we see the break at x equals -5 where one of them doesn't include it but the other one does. So it's discontinuous at x equals -5. And then it says, does this graph represent a function, y or y not? And so remember, we can use the vertical line test to determine if a graph is a function, and we can see that for the most part, our lines only intersect at one point. Now you might be saying, oh no, it intersects at 2 points right here at x equals -5, where it's discontinuous. And we see it going through this point and this point. And what we have to remember is that since this point is open, remember it's not included on this graph. So even though our vertical line is going through this point, it's an open point, so it doesn't count. So this vertical line is only passing through x equals -5 right here on this graph at -5, 0. It's not passing through the point up here because it's an open circle. So for that reason, we can say that yes, this is a function because every x coordinate is paired with only one y coordinate. And lastly, of course, there's a lot of focus on where this graph is discontinuous. So our next question says, what is the y value when x equals 5? And this confuses a lot of students because, again, we have these two circles. But again, just focus on the open circle not being included and only the closed circle is included. So the closed circle is where we want to focus when x equals -5, and then the y value is 0 because this point is -5, 0. Okay, so this is just an introduction to piecewise functions, and basically